This is a short learning in the open video about LiteBox announced earlier in February. Lots of people in Hacker News were asking what is a library OS and how can this be used and what are some good, quick start instructions that could help people start to get an understanding of this project. And certainly there's a lot to learn from LiteBox. There's a lot that I've yet to learn about LiteBox. But today I'm going to be focusing on the Linux shim blue box and the Linux userland green box. The way I understood it, LiteBox has two groups of interfaces. The north interfaces are what your regular application, untouched application, your existing application would know how to talk to, and your green set of interfaces are the ones that help a runner to be the orchestrator and sandbox manager of your application in one of these different platforms that you got here. So again, today I'm going to be focusing on the blue Linux shim box and the green Linux userland box that essentially led a Linux application to be sandboxed inside of Linux. So there's activity in several other parts of the code, and that there's an area just to learn more about. But certainly some of these quick start ideas were not present in the README at the time that I recorded this video, so I used Copilot CLI and Claude to put something together that I want to walk you through so that it hopefully helps you get an understanding of this and other library OS projects as well. So looking at what we have here really briefly, we have a glorified Hello World application here that also do some memory allocation, some getting process ID, and certainly a lot of printing, which will just generate a lot of syscall activity, which we'll look at in just a second. Then I also have two Nix files right here. I have a Nix file to help me build my statically linked Hello World application, and I have another Nix file to help me build LiteBox itself, which is a Rust project. And I kept those separated because certainly for the the one for my Hello World application, I want to statically link that binary. And obviously for the Lightbox one, I do want Rust and Make and I want to keep those two separated because I don't have any of those development dependencies here in this environment that I'm currently typing in. So for convenience, I have a build.sh, which will call Nix shell with those and then get everything built. And I have a run.sh, which will run the application. Let's go ahead and run my build. And once this is complete, I'll have binaries both in my target folder. So if I want my userland, for example, I'll have my userland artifacts just built here. And then for my build, I have everything here in this underscore build folder under my examples. And obviously hello would be my statically linked hello world application. And then this one I can just execute and it runs just as any other Linux application would run. By the way, you can do this exercise with any other statically linked Linux binary that you want. I've tried with a couple, and that's a nice exercise because you get to see what different behaviors and syscalls do. So one thing is that I mentioned if I run the application again, but I'm just going to trace it, then I do get a lot of syscalls and you get a lot of writes. I get some get PIDs, and so this is going to come in handy later because I want to run this in the debugger to show you a couple differences between the two execution modes of this. Alright, so now that we have this, I can go ahead and show you my run.sh. So the run.sh is very simple, and the part that matters is right here. Basically, I'm calling my Linux platform userland runner from the LiteBox project. I'm passing unstable and passing interception back in rewriter. These two options here were included by the coding agent, but we're actually not going to use them. And then the path to my guest application, which again is my statically linked Hello World application. Once I run this, then I just get some front matter here, and then the application runs and is there just hanging waiting on my input, and it all it runs as expected. But what I want to do now is run this in the debugger to show you the difference between a couple of things here. So I don't have a debugger here either, so I'm just gonna Nix shell it as well. First, I'm gonna run my statically linked hello world application. So that is on examples, under build and hello. And I do want to catch on the write syscall, just because it's convenient and I know that it's there, but I could do it on get pid, I could do it on malloc. Once I break, I want to run a couple commands. I just want my instruction here, and I want backtrace, and I want mappings, and I think that's it. And I can go ahead and run this. So here I am, and in this address, it corresponds to a section that is in my elf image. It is a stack that is 6 deep, and I'm right here on top. And I see that this address corresponds to an executable portion or executable mapping of the elf image itself. And that is all the type of stuff that I am expecting to see in a statically linked application like this one. Now let's change gears and look at how would this look like once I run it on the LiteBox platform userland runner. So for that, I need to look at target release and then find the LiteBox runner Linux userland. And then I want to run with a set of arguments, and those arguments are the ones from my script right here. And as I said, I'm not gonna need all of them, so I only need unstable, and I need interception backend rewriter. I'm just gonna copy it so I don't have, and I need the path to my guest application, which is my hello world application. I can use this full thing right here. There we go. Okay, and I have my breakpoint and my command set, so I'm just going to go ahead and run and say yes here. And now the first thing I'll notice here is that I am in a stack that is 16 deep, and that no symbols were resolved, and that in the address that I'm in right now corresponds to an executable portion that is not mapped to any elf image anywhere. And that in the mapping, I also see I have my own hello statically linked application mapped in here, along with other things like libc and the dynamic loader. And of course, that's, the parent is the runner itself. So this again just would show me exactly what I would expect from these sandboxing using that interception mode of rewriting, right? There's another interception mode if you're curious, and that is seccomp. And this would do a couple syscalls and has an allow list and a set systrap based mechanism to intercept these syscalls. But this is right now not working, at least for me, at least with this app. Once I do this, I'll get a bad system called sixes, and then the handler for that doesn't seem to be configured correctly, because then I get a segmentation fault. But you get the point. Generally speaking, in this scenario, what we have done is to run an unchanged Linux application that understands or expects what the Linux shim implements here in this north interface, and then it has a Linux userland runner. And like I said, there is activity in the repository pointing to other interesting things, especially in the space of the Linux virtualization base security, LVVS, and Windows userland. I've been able to run some statically linked Linux binaries on Windows userland using code from this project. So again, I encourage you, as I'll be doing, just learning from all the different portions of the project and implementations of this. It has been an interesting learning for me, and hopefully this video is useful to you as well. Thank you for watching, and take care.